We're here today, obviously, to talk about the FDA granting an emergency authorization of the Pfizer vaccine for COVID-19 in adolescents and I think 12 to 15-year-olds, in addition to the 16 plus that it was already approved for. And I think a lot of parents will probably have questions, especially if they're maybe vaccine hesitant a little bit. Could you talk about the emergency authorization? And something that keeps coming up on our Facebook page, for instance, is that people don't want to get the vaccine until the FDA has given it a full authorization or full certification. Do you feel confident that the emergency authorization is adequate to ensure that it's safe for teenagers?
I do. So the emergency use authorization is what it sounds. It was authorized for emergency use during the COVID pandemic. It is different than a full FDA authorization. And so that is an important distinction. But when you consider how many doses have been given and studied, this is actually much larger than you would have seen in a regular set of vaccine trials. And we have seen very good safety profiles with the Pfizer vaccine, which is the one in question right now. And so, yes, I do feel safe about it being administered to children in this age group.
And do you have any concerns about so this is kind of piggybacking on what you just said, do you have any concerns about the rigor of the testing, either for adults or for kids? And can you perhaps just expand on why you believe it's been tested rigorously?
So at this current stage, the vaccine has been sent through the usual hoops that other vaccines need to go through and tests and trials before it reaches the stage 3 testing process. And at that stage is when we start looking at how it responds in populations. And so the safety of the vaccine itself has not been compromised, or the testing of the safety has not been compromised in any way in terms of how quickly it has moved through. We've just moved into the administration of the vaccine sooner than it would be for other vaccines. And once again, considering how many people have received the vaccine so far and the safety profiles that we've seen with this in terms of data collection, it looks to be very, very safe.
And so that kind of brings me to my next question too. Does this vaccine have any similarity to other vaccines that teenagers might have already received in terms of the technology used to develop it? Or, well, yeah, I guess in terms of the technology used to develop it or the way the vaccine is structured, would it in any way be similar to a chickenpox vaccine or, you know, the is it the MMR, the measles, mumps, rubella? Yeah, are any of those similar?
So this vaccine is distinct from those other ones in that it uses something called mRNA technology versus just being protein parts or, say, a weakened virus in the case of the varicella or the MMR vaccines. And so the way this works is that it takes a small little bit of mRNA. That's, you know, part of what encodes for protein to be produced. And it's coated in, you know, they say nanolipid membrane, which is really kind of a fancy way of just saying it's more or less a fat droplet. And that's important because that little fat droplet's necessary for that messenger piece to enter into the cell so that the protein can be made and then the immune response can be achieved. In the cases of the other vaccines that are on the standard children's immunization guidelines, they are given most of the time either parts of a virus or a weakened virus, and the immune response is generated. So that's how it's different.
So in this case, kids, adults, they're not receiving a weakened version of the virus. Is it sort of like they're receiving a copy of it, or a facsimile that trains your immune system? Is that a fair way to describe it?
Yeah, it's sort of. They're not even receiving instructions to produce the whole virus itself. What they're receiving are instructions to produce just the spike protein on the virus. So you've probably seen those pictures of the coronavirus that we love to put up on newscasts, where you've got the sphere and all these little things that stick off of them. Okay, those are called spike proteins. And what happens is that the spike protein on the virus binds to a receptor on your cell, and the virus gets pulled into your cell. Viruses are protein particles that contain genetic material on the inside, either DNA or RNA. And that then gets transcribed through your cell's machinery to reproduce copies of itself. Eventually, it produces a ton of copies of itself, and then it kills the cell and it leaves and it goes on to the other cells. So what's going on with this particular vaccine is that we're giving patients the strand of genetic material that only produces that spike protein. So it doesn't produce the entire virus. It's just producing that little part there that is normally what binds to the cell to get pulled in. So that gets, the genetic material gets transcribed to produce just that spike protein. It leaves the cell, and your immune system recognizes it and says, intruder alert, learns how to fight it, and then it defends you against anytime it recognizes that spike protein when it sees it in the future. So instead of seeing the entire virus, you're just seeing that little part of it. So we're not training your body to make a whole virus. We're only giving it a page of the virus's code book to read. And it reads that one page, produces just that little segment of the virus, and that's what your body's learning how to fight. It's the important segment of the virus because it's the part of the virus that binds to your cell.
And that brings me to my next question too, which is, what do you tell people who are afraid? And I know that you've kind of explained this, but what do you tell people who are afraid that this might change their DNA or their child's DNA? Because that is a rumor that's out there, a little piece of misinformation, if you will, that people are receiving from different sources. This is not altering someone's DNA, I take it.
It's not altering DNA at all. So, there's two parts to remember about this. Part number one is that this is RNA. And you might remember back to your biology days that you see, cells have that double helix, that wound up piece of DNA, right? So that's all the instructions for the DNA in your cell. And that gets unwound, and then a copy of that is made that gets sent out to other parts of the cell, to the machineries, to the factories that go and produce the proteins that you need. It's not realistic at this stage of life and technology to be able to take RNA, that messenger component, and get it reversely transcribed back into DNA and incorporated onto your cell. And so that alone helps protect you from any kind of intrusion onto your genetic code. Another thing about this is that mRNA strain, as it binds to your cell, you got to remember, it has a very, very short life. It is not a particularly stable molecule. It comes apart really easily, which is why we need to encapsulate it in that fat globule so it can bind into your cell. And so it doesn't live very long once it makes it into your cell, and it only has so much time to be able to be turned into that spike protein that's necessary. In addition to that, your cells are very fascinatingly complex things, and they actually contain components of your immune system to actually help knock out random strains of RNA that happen to end up in your cells. This can be picked up from all sorts of things. Other viruses can do this, so it's a defense mechanism against that. If the cell next to them happens to die and some of that genetic material happens to work its way into that cell, these defense mechanisms help to degrade that genetic material. So it's not, if we could introduce DNA into a full-grown person and change their DNA, we could cure a whole lot of different diseases. And so unfortunately, we can't do that yet. So this is not a major concern with this particular vaccine type.
What kind of side effects can teenagers expect if they receive the vaccine?
Generally speaking, we see the same side effects in kids that we've been seeing in the adult population. That is to say, a sore arm is the biggest one, right? You might feel fatigue, you might feel down, get a little fever, headaches and dizziness. Those are the primary side effects that most people are complaining about when they get the vaccine.
Now, I know there are also a lot of people out there who are saying, well, for the most part, kids aren't getting as sick, or younger people aren't getting as sick if they contract COVID-19. Would it be better for them to just get the disease and develop the immunity that way rather than getting the vaccine? Why should people consider having their teens vaccinated?
So although you might not see as many serious cases children as we see in the elderly population who gets COVID vaccine or gets COVID-19, excuse me, it's not an entirely benign disease in children either. We have children who have still suffered pretty significant illness from the disease, and we have measured deaths from this disease as well in children. Also, although they are somewhat protected, it seems to be because of their age with it, vaccinating them will also help prevent them from being able to transmit this to grandma and grandpa as well, and will also help protect other members of the family.
That was going to be my next question too. Does it make it easier for them to socialize either with their friends or with older relatives if they are also vaccinated, even if grandma and grandpa are vaccinated?
So yes, it should. Now the CDC hasn't fully released some guidelines on that matter yet, but we expect that will be coming, and so it should be protective for them. I would also say that, interestingly enough, when it comes to why get the vaccine versus natural immunity, in terms of that, there's some very important and interesting data and studies on that. Number one is whenever your immune system sees a pathogen, sees a bacteria, sees a virus, anything that causes disease, right? You generate some immunity. When you see it the second time, you generate a ton more of immunity than you did that first time. And so when it comes to the Pfizer and Moderna vaccines, in this case, we're talking about the Pfizer vaccine because it's the one for which the EUA has been authorized so far, and Moderna will probably be coming not too far in the future. You're getting that first introduction, but you're getting a second introduction in a controlled environment, by the way, 3 weeks later. And so this substantially increases the immune response that your body produces to the virus, and that's very valuable. There are studies out there that actually do measure titers and can talk about how numerically what kind of immune response you see when you have the disease and when you receive the vaccines. And the response that you achieve post-vaccination is substantially higher than it is when you've just seen the virus for the one and only time. So that is also another reason why you might want to get vaccinated instead of waiting to encounter the virus on your own. And another one is the emerging variants that we're seeing. It's interesting because in some parts of the world, we're talking a little bit about so-called escape variants. And these are variants that have been able to, for various reasons, sidestep immunity. And one of the things that we're seeing is that although natural immunity has been sidestepped with a few of these variants, the vaccine immunity might be partially sidestepped, but not to the same degree that the natural immunity is. So the vaccines are actually even more protective because they may give you some protection against the variants as well.
And so even if someone has already had it, even if you're 15 and you've already had it, you would still recommend at a certain point getting the vaccine even after having contracted?
Yeah, I certainly would. So on the one hand, the virus is still novel, right? It's still new. We're still learning just how long the immunity lasts from the virus. But remember that second exposure dramatically increases your immune response to things. And so if you've seen the virus once, you are more likely to be more protected if you get the vaccine on top of that. And that will improve your ability to defend yourself against the virus. Also, when it comes to the variants, one of the things that is under study is you might not need to just give a, we talk about whether or not you'll need a seasonal dose or something like that, kind of like you see with the flu. And some of the companies are working on variant specific doses. And there's a lot of research that's indicating that you don't need a variant specific dose as a booster. You just need more of the exposure so that your body produces enough titers, because these vaccines are not showing that so much that the variants beats them as much as it just takes longer to neutralize. So the vaccines are still protecting. It just takes longer to neutralize. And so, we may see a time come where you need an additional dose of these vaccines that might not be any different than the doses you've received, just because that can further elevate your immune response. And so if you've already had the virus, receiving the vaccine is still beneficial because, once again, it elevates your immune response.
So that was something that I had a question about, and I received, both doses, and I received Moderna. But my understanding was that each shot was pretty much the same. It was just elevating your immune system response by getting that second dose, or elevating the efficacy. So is that, if we have to get boosters a year from now, is that the same thing where it's still?
It's similar, yes. The jury's still out on exactly how much waning immunity we're going to see from the vaccine. Because, once again, as we said, this is an emergency use authorization. So the vaccine, we can't draw, go to our time machine and draw titers 5 years in the future and see what it's going to be. We still need to see that. But definitely through 6 months, the titers seem to be holding pretty steady. And that's really good news. They may fade over time, but I think that what we're probably more likely to see is, with the variants everybody hears about in South Africa and Brazil, the UK variant seems to be pretty well defended. But some of these other ones, that getting an additional dose of the vaccine will provide you with even more troops necessary to fight that variant.
There's a lot of discussion too about schools, not just colleges and universities, but even middle schools and high schools requiring this vaccine for people to come back to school. Certainly schools already require some vaccines. Does Boystown Pediatrics, do other healthcare providers, are they kind of staking any sort of opinion on whether or not students, in order to come back to in-person school, should be required to receive a vaccine?
To my knowledge, none of the healthcare systems in town, at least from pediatrics, are saying that we feel like this should be a requirement to go back to school. I think that certainly at Boystown, we all agree that we encourage our patients to get the vaccine, and we're supportive of them getting the vaccine, but I don't know that we're getting into more public policy than we are my role as a pediatrician in health.
Yeah, thanks for answering that. I figured that wouldn't be, that's not really your choice or your decision there, but I was curious to see if doctors had an opinion about that. I don't have any other big questions. Is there something else you want your patients to know, that you want the public to know, or anything that is, any misinformation that's frustrating you about the vaccine?
I would definitely say that I want my patients to feel that encouraged to get the vaccine, and that I am supportive of the vaccine, and that I feel that is at this time the best defense that we can give you against the virus, which, although it's not necessarily as dangerous in children as it is in adults, is still not an entirely good thing for kids to be getting, and can be very dangerous for them as well. I suppose some of the myths that I hear about the vaccine, you brought up, will it change your DNA? And it's like, well, no, that one's just not really biologically possible. I've heard some people say that it contains a microchip, and that will somehow allow people to track you. And it's like, boy, if you could get a microchip that small for tracking, I know that Apple and Google would be all over that one. But, where I think some of that comes from is there was a idea produced at one point in time about using a dye. There's almost more like a tattoo that could be left on the skin, and that could ensure vaccination status. And you might wonder, why would you need to do something like that? And the answer is, well, pretend you're a medical missionary and you're working in, a third world country that doesn't have very good healthcare records. And you're working with manual laborers who you might say you can track them with a fingerprint, but you know what? Their fingerprints change because they're always working. And you try and get birthdays, but no one can give you an accurate date of birth because, well, people aren't using the same calendars. They might say, oh, yes, I was born, 2 months after the full moon or something like that. And it's hard to keep track of who's who. That was why that technology was discussed, so that when, someone shows up to their local Doctors Without Borders camp and they're looking for a vaccine, they might know what they've had, but there's none of that in this vaccine. So there's no microchipping going on. People have had concerns about fertility, and of the people that they've tracked, they have not seen an increase in infertility associated with COVID-19 vaccination either. So that's important to be reassured about. There's a lot of other ideas out there about these vaccines, but the vaccines so far have been shown to be effective, very effective actually, at defending against COVID-19 and its severe disease. And they have been shown to be safe, and I would encourage my patients to get them.
Well, that actually just made me think of one other issue that comes up, and it comes up a lot on our Facebook page, is that people will say, well, 99% of the people who get this survive or they recover. But I do know that there are long haul COVID patients. I know there are even some concerns that the MIS-C virus, that might have a relationship to little kids getting COVID. And so while most people who get COVID do survive, what are some of the potential side effects even in teens, or even in their younger siblings who can't get vaccinated yet but could still contract it?
And part of that are things that we're still learning and seeing, but certainly COVID-19 is a wrecking ball. I mean, almost anything in the world can be associated with it. And, we're having cases where, a few months down the road, the child is developing diabetes. And even though they had a seemingly benign course early on, it seems that this has been a event triggered by the virus. When it comes to MIS-C, for example, a lot of those kids, frighteningly, had very benign courses. And then about 6 weeks or so after they've had the virus, then they go on to show us a severe multisystem inflammatory syndrome. And so even though your experience with the acute course of the virus might seem light, there are definitely long-term things that can happen down the road. And that's another good reason to protect yourself with the vaccine.
And we think some of those long-term symptoms might actually be causal and not just correlation, but actually caused by having contracted COVID at some point.
Right. Now, certainly there are some things that just happen. I mean, we mentioned the diabetes. I mean, that can, that kind of thing can show up, but when they look back at it and they can exclude other confounding factors, we are actually seeing risks of other secondary consequences from the virus.